In this video, let's have a look at all the copy, mirror, and move functions. But before I can do that, I'll need a couple of components. So quickly redraw the ones we had in exercise number 6. So we have a column 12 by 79. Perhaps, okay, change the grade. That's what happens when you type in. So let's change the grade. So over here, although I could just do with one, will be enough for now. And a rafter W12 still but 35. Change position slightly, 1 and 2. So just a column and a rafter or a beam. There is a copy menu over here, not to be confused with the menu we have over there, which is only focused on 2D components, so graphical components, not 3D elements. So we need the menu just next to construction, where we have the possibility to copy by dimension, by points, by angle, via distribution, mirror, move by dimension, move by point, move by angle. So in this situation, we would need something like a mirror. Call up the function, right mouse click. We're going to copy over 2, 3 points. You could copy over 1 point, but I personally prefer the 2, 3 points. And just for your information, you must know that later on when we will bolt and weld components, Bocad will always search for something else to grab onto. If that is not possible, we still have the possibility to say, okay, you loosen the connections or you delete them, or in some rare cases, you keep the partners. And under info, there'll be some checking capabilities running in the background. So what are we supposed to do? Okay, select the components either with a window or you just pick them one by one, whichever you prefer. Enter, and then you pick the 2 points of the mirror plane. Confirm with enter, and we got our mirror. Do that again. Select the components, enter, and for a change, I'll pick the mirror plane in a different view. So it doesn't matter where you work. You could even do the following. Pick a component here, pick a component there. Bocad knows what you're all about. Enter, mirror plane, enter. That's one. Copy. We can copy by dimensions. So if I were to copy this over the various axes, I would need 16 feet 4 inches, 20 feet 6 inches, there again, and another 16 feet 4 inches. So I would copy by dimension. Now you have to be a bit careful about the UCS, so the coordinate system of the view you're using the function in. If you're using this in a 2D view, then the horizontal axis is X, vertical axis is Y, and depth is Z. Now, if you're working in a 3D environment, it's a bit different. This over here is X, this is Y, and Z is up and down. So what do we have? I could type everything in, but let's face it, typos are not impossible. So what I could do, pick this little icon, measure, what's the distance here? Pick the distance, unfortunately it's set to member, so we'll say I'm gonna pick points. What's the distance? Actually not an X, but an Y. 1, 2. It measures the distance, comma, 1, 2. This is the value we need. So if it's just for a single value, it can always be useful. Well, let's go on. 2 colon 2.5 feet. I'll just make a couple of copies. Okay. Select over here. And there we go. Undo. Call up the box again. I cut these values and I'll paste them in Z. Now I have to place this as negative values, like this, to push the elements away from me. So that would be very useful in a 2D environment. The one I personally use a lot more is copy by points. Right mouse click to see the options. Make sure you use the multi-copy. OK. You select the components you would like to copy. Enter. And you'd say we go from here, enter, to there, enter, to there, enter, to there, enter, and there, enter. If I now were to copy with 2 points, select the components, enter, from here in that direction, enter, to there in this direction, enter. So that would allow you to sometimes rotate or flip the copied components. There is also a copy by angle. 3 times 90 is perhaps a bit exaggerated. Let's say 90 degree. OK. This is the rotation point, and it will just rotate around the picked point. Again, be mindful of the view you're working in. So if I say this over that point, you're of course always using the local or the view's UCS. If you were to add an offset for each copy, you could go as crazy as saying 10 times 15 degree. Every copy has an offset of 12 inches. OK. It's not too representative right now, but pick the element, pick a point, and each and every copy will have an offset. This would allow you to cover certain situations of, for example, a spiral staircase. We're not in that right now, but you get the picture. And then there is a move by dimensions. So if I were to say we're going to move this, it's not necessary, of course, to have several values there. I would just add one value in the field to move it over a certain value. Move by points, the idea being pick the elements, enter, pick the original point, enter, pick the arrival point, enter, or pick the components, enter 1, 2 points for an original direction, 1, 2 for an arrival direction. And then finally, move by angle. This is not necessary, of course. OK. Pick the components, enter, pick a rotation point. There we go. Now, if it's a negative value, it will rotate in the other direction. And then there's distribute. We can see over here. I personally find this very useful for purlins. So let's see if I make a distance lengthened 10 inches, and I would say there and there. And I would create a purlin, W8 by 13. I would say I'll create this perpendicular to my view. That's my anchor point. It's away from me. I'll make it 16 feet 4 inches. There it is. And I'd say anchor point here, this direction, there goes the purlin. Now, if I'd say this purlin I needed a couple of times over a certain distribution, a little bit like what I would do with the points, where I would say divide line over various logics, and then I would copy the purlins or just create them on those new snapping points. I could also say distribute, right mouse click to call up the setting box. How many copies do I need? Well, I need 4 copies in between. Pick the component we would like to copy, enter, this direction, enter from there to there. and then there will be a division. So not on the last point because it's intermediate. Right mouse click. We could also say maximum distance, so equal spacing but without exceeding a certain picked value. So from there to there, over here and here. So we will have an equal division in between the purlins, but without exceeding 5 feet spacing. Right mouse click once more. I could also say, give me 5 feet fixed spacing, and whatever is left, leave it towards the second point, such as this. Well, it's very close to the second point, but still it works. And then there is also res P1, P2, where we would say, well, maybe not 5 feet, because we saw what it gave. Let's do 4.5 feet. There, from here to here, and there we go. So we will have an equal spacing of 4.5 feet, and whatever is left is divided on either side. So especially for purlins or girts, or sometimes even floor beams, it can be a pretty useful function. It's a combination of points, divide line, and then later on copy either by dimension or rather actually more copy by points. So now you know these functions, you could see how you could actually make the previous exercise number 6 in a lot faster way than you had so far.